right, welcome to math. So we are using the CPM Integrated Math 1 book this year. And so they kind of number things a little bit oddly. So when we say this is lesson 1.1.1, it's a lot of ones, this means chapter 1. And then in chapter 1, we're in section 1. And then we're in lesson 1. So the next lesson will be 1.1.2, and so on and so forth. So chapter 1, section 1 of the chapter, and we're in lesson 1. This was going to talk about function machines. And we're going to kind of pretend throughout this lesson that we are part of a factory that makes numbers. So yeah, factory that makes numbers. So we're going to make machines. The machines are our functions. And we're going to put things into the machine, and we call these inputs. So right now our input is going to be 3. The machine's going to do all its work to it, and then it's going to spit stuff out. And in this case, it's outputting 8. Now, between the input and the output, there's some kind of transformation going on. And this particular function is x squared minus 1. So we want to be able to explain in words and describe that function in words. So if I were to describe this, since x is the input, I would say here that it looks like it's squaring the input and then subtracting 1. So we're going to say that this function squares the input and then subtracts 1. So we're using our order of operation. So that's what our function does. So it put in 3. 3 squared is 9. And then it subtracted 1. So 9 minus 1 is 8. And that's why our output was 8. All right, so the next one. So let's say that we've got this function machine company, and we've got a customer. The customer comes along and says, okay, I've got this huge box of integers. So integers, we have to kind of talk about what an integer is. An integer is the positive and negative whole numbers. So no fractions, no decimals. So we're talking about the positive and negative whole numbers. So that could be -5, it could be +1, it could be 0, it could be 20. You just can't do like 20.3 or something like that. So it has to be a positive or negative number. So let's say that our customer comes and he's just got a huge box of integers. So this could be any integers. And they come in and they say, okay, I've got this huge box of integers, and I want you to design me a function where the output is always negative. All right, so we've got a manager in this shop, and he says, okay, I've got one for you. -x/2 minus 10. So if I'm describing this, I would say the input has its sign changed. That's what the negative means. It's like multiplying by -1. Then it's divided by 2, and it's subtracted by 10. All right, so we have to ask ourselves, is this a good function for a box of mixed integers? So did our manager of our store come up with a good idea? So what I want you to do is think of, are there any possibilities where this answer would not come out negative? Like if I plugged in 6. If I plugged in 6, I would get -6/2, which is -3. And then -3 minus 10 would be -13. So for that specific integer, it does work. But does it work for every single integer? Is it possible to come up with any number and have it always be negative? So try to come up with numbers that will not make it negative, where you'll get a positive answer instead. You might want to pause it or whatever. Kind of think through some numbers. All right, and we're going to find out that no, our manager is a fool. This is not a good choice, because if we put a negative number into the x, a negative number is actually positive. So Once I plug in negative 20 to here, I get negative 20. So if I plugged in negative 20 into the x value and divide by 2, this ends up being 20 over 2. And 20 over 2 is 10, so I get 10 minus 10, which is 0. 0 is not a negative number. So what other numbers would also give us a positive answer instead? Well, any number smaller than negative 20, so negative 22, negative 23, negative 24. So this is not a good fit. So we could think of numbers. We might say, are there inputs that don't fit? Yes, there are. Any number smaller than negative 20 or smaller. And here's how we write that. We would say x is less than or equal to negative 20. Negative 20 doesn't work because that makes 0. Negative 21 would make positive 0.5. Negative 22 would be positive 1 if I plugged it in. So any number smaller than negative 20 or equal to negative 20 is a bad fit for this. Now, if our customer came in and they only had positive integers, positive numbers, then this would be a good function if they wanted a negative answer. But since they just have a box of mixed integers, maybe one of those integers in that box is a negative number like negative 20 or negative 22 or something like that, so it's not a good fit. All right, next one, 1-3. So we've got a function here. Our input is negative 1. Our function is 3x plus 1, so that means we're going to multiply the input by 3 and add 1. And we want to find out what the output is. So when we plug these in to work them out, I want you to plug them in parentheses because sometimes it matters. So I'm going to plug in negative 1 plus 1. So I get negative 3 times negative 1 is negative 3 plus 1. Negative 3 plus 1 is negative 2. So my input of negative 1 gives me an output value of negative 2 using the function. All right, next step. What if the customer, oh, I forgot this last part. That was only the first part of it. There's two functions together. I forgot that. All right, so that's where the function goes into here. And so the output is negative 2. But these two functions are set up next to each other, meaning that once this function spits out negative 2, the next function is going to make that its input. So I'm going to plug in negative 2 into this next function. So negative 2 squared. Okay, if I do negative 2 times itself, I get positive 4. So when you set up multiple functions, the output of one becomes the input of another one. So in this case, I started way up here at negative 1. This function made it the output of negative 2, which we input to this function and got positive 4. All right, so let's say that we set up these functions for a customer, and the customer ordered a negative number. They're like, hey, I want a negative number. Give me a function that's going to give me a negative number. Would this give us any negative numbers? And if not, I'll just give you a little hint here. It's not going to give you any negative numbers. Why would this function here, this set of functions, not give you a negative number? Well, the answer is because of squaring. You see what we did here when we squared a negative? It became positive because a negative times a negative is a positive. So what if the customer ordered a negative number for this one? It's not possible. Because the output will always be greater than a negative number. It'll be either 0 or it'll be a positive number for this one. It is not possible. The output cannot be negative. By B negative. Words are hard. Okay, so the reason why it can't be negative is because squaring always makes your number positive. So if you square a negative real number, it becomes positive. All right, next one, we got a little bit of a challenge here. All right, so this is 1-4. So we've got an output of 0, or sorry, input of 0, and an output of -31. And this time we've got 3 different functions. And I've actually got those functions right here. All right, so I've got these 3 functions. And our input is 0. Our output is -31. Now, one way to solve this problem, if we had to set up a group of functions, one way to do it is just to try all the different combinations. And since we have 3 things, and maybe you're good at combinations, you would know there's 6 different combinations for 3 things. But that's a lot of time wasted if we have to check every single one of the combinations until we find one that works. So sometimes we want to look at, well, what's possible to start, what's possible to end, and see if we can narrow down our choices. In this case, we can narrow them down quite a bit. Remember, we're starting with 0 up here, and we're trying to get -31. So looking at these 3 functions, which cannot be the last function? Okay, so our output number has to be negative. Which one of these cannot give me a negative number? Well, we saw in the last one, if you square something, you can't get a negative number. So I know that my last one cannot be x minus 2 squared. Not going to work. Okay, so I know this has to be the first or the second one. So I'm just going to put this to the side. You, my friend, are the first or second. Because you can't be the last because we need a negative number at the end. So you're 1 or 2, put you to the side. Next question, which can't be the first function? Okay, our input is 0, so which one of these might not give us an answer that's good for 0? Well, this one, if I plug in 0, I get -32. But this one, if I plug in 0, I get 1 divided by 0, which is insanity, because basically that's saying, okay, I've got no pizza, 0, and I'm going to give you 1 piece of it. I'm going to give you a piece of nothing. That doesn't make sense, and it doesn't exist. You can't give something 1 of nothing. So you cannot have a 0 in the denominator. So we know that this one cannot be the first. So that one's not the first. This one's first or second. So which can't be the first function? So this one. Oops. So 1 over x. Now let's see if we can find anything else out. So this one is not the first. But you know what? Now that I think about it, it can't be the last function either. Because most of the time, won't this one give us a fractional answer? Like if I plug in an x down here, if I plug in 5, this would be 1/5. My output needs to be -31. And this is going to give me a fraction. So this is not the last. Okay, so now I know this is not the first, it's not the third, so this must be the second function. Well, this one was the first or the second, and we know that this is the second, so this one must be the first. And that leaves us with this function right here, must be our third. Let's see if it works. Okay, so we said that we're going to plug in an output of 0. So 0 goes into this. 0 minus 2 is -2. -2 squared is 4. So there's my input of 0. My output is 4. Second function, I said, was this one right here. And now our input for that one is the output of this one. So I'm going to plug in 4 here. Okay, so 1 divided by 4 is 1/4. So the input was 4, the output is 1/4. Sweet, almost there. The input of this one is 1/4. Okay, 4 times 1/4, or we can say 4 divided by 4, because that's what 1/4 means when you're multiplying. So this is 1 minus 32, which is negative 31. And there's our answer. It works. Our input was 0. It gave us 4, went into this one, gave us 1/4, went into this one, gave us negative 31. And we didn't have to check every single one because we could look at the possibilities and decide that certain ones could be first or last or whatever. All right, so this is your little trick here. You need to have an input of 1/7 and an output of 36. All right, so I want you to work on that. Give yourself a second. Here's your different functions. Your input is 1/7 and your output is 36. Try it on your own. Don't just watch me do it, because that's not going to help you at all. So you want a 36 at the end, 1/7 in the beginning. Did you notice which one needs to be first? Well, it can't be this one, because that's going to give us a huge fractional number. Probably not this one, because that's going to be a fraction. What if I put 1/7 here? What's 1 divided by 1/7? Well, if I plug in 1/7 here, 1 divided by 1/7 is the same thing as 1 times 7. Because remember, you have the rule where if it's 1 divided by a fraction, then you're supposed to change it to multiplication and take the reciprocal of this other number. So this becomes 7/1, which is 7. So our first function would be 1/x. So here's our machine. We're going to put into it 1/7. The output is 7. Our next machine, so now we only have 2 to choose from, which is nice. So I've got these 2 to choose from. I want my output to be positive here, so that's something to think about. If I plug in 7 here, I get a negative number, which is okay. So if I plug in 7 here, I get 28. But if I plug 7 into this one, I've got 25 is my output for that one. So if I put 25 in here, I get 100. And then 100 minus 32 is not 36. So I don't think that this one's next. This one might be next. Let's check it out. 4x minus 32. So 7 times 4 would be 28. And 28 minus 32 is negative 4. Okay. So our last function, that's a horrible square, but I'm going to deal with it, is x minus 2 squared. So if I do negative 4 minus 2, that's negative 6. And negative 6 squared is positive 36. So there's the order. 1/x first, 4x minus 32, x minus 2 squared. We've got our order for our things. All right, we have one last problem. Here we go. So on our last problem, we're going crazy on this one. So I'm going to have 4 function machines now. I've got negative 2x plus 34. I've got negative x over 3 minus 10. negative absolute value of 3x, and x minus 2 squared. So this one, you're going to multiply the input by -2 and add 34. For this one, you're going to multiply the input by -1, divide it by 3, and then subtract 10. For this one, you're going to multiply the input by 3, take the absolute value, which means make sure the number is positive, and then make it negative. So this one's always going to give you a negative answer. And this one right here is just like the one we did before, which will always give you a positive answer. So this one always gives you a negative answer, and this one always gives you a positive answer. This one gives you a fraction a lot of times. So think about this one. You really want a number that's divisible by 3 if you don't want fractions. So keep that in mind as you're deciding which one to choose. So these 3 over here have definite limitations. This one's always going to give you a negative because you're going to take the absolute value and then make it negative. This one's always going to give you a positive, so keep that in mind. And this one will give you a fraction unless the number you're inputting is a multiple of 3. So I want you to work on these next two on your own. I will give you the answer at the end. So the input is 15, the output is -6. And then what if the input was 8 and the output was 2? All right, so if you can pause, that would be appreciated. So if you pause and then work these out and then check your answer, we will do that. Are you paused? You're not just waiting for me to give you an answer, are you? Pause. All right, 3, 2, 1, here we go. Here are the correct answers. This first one should be -2x plus 34. The next function would have been x minus 2 squared. The next function is negative absolute value of 3x. And then the last function on this one is negative x over 3. And then minus 10. So that's the correct order for that one. If you plug in 15, you get -30 plus 34. And -30 plus 34 is 4. If you plug in 4 here, 4 minus 2 is 2. 2 squared is still 4. If you plug in 4 here, 3 times 4 is 12, and then we make it negative, so that's -12. This one, we do -12, which is +12. +12 divided by 3 is 4, and 4 minus 10 is -6, and we get it to work. For the second set, here are the correct answers. The first one should be the negative absolute value of 3x. And then the second one is negative x over 3 minus 10. The second one, or the third one, is x minus 2 squared. And the last one is negative 2x plus 34. If I plug in 8 here, 3 times 8 is 24, and then the negative makes it negative, so that's -24. If I plug -24 here, and -24 is a +24. 24 divided by 3 is 8, and 8 minus 10 is -2. -2 minus 2 is 4, -4. -4 squared is +16. And then -2 times 16 is -32, plus 34 is +2. All right, that is the first lesson. We do have, at the end of a lot of our lessons, something called methods and meanings. These are kind of introductions to concepts that you'll see in your homework, and some of them you might already know, some of them might be completely new to you. So you do need to add these to your notes. So in this one, they're going to talk about absolute value. Now, absolute value, as we saw in that last problem, is when we always get a number that is an even number. And the reason why that does it is anytime an absolute value, numerical value is the number without its sign. The reason why is it's talking about the distance from 0. And anytime you measure distance, you always measure with positive numbers, like forward 3 feet is still 3 feet, and backwards 3 feet is still a distance of 3 feet. So distance is always calculated as a positive number. So -3 is still 3 units from 0. We don't care that it's -3, it's just 3 units away. +5 is 5 units from 0. So absolute value is just looking for the distance from 0. So it's always going to be positive. Now, when you have an absolute value sign, they kind of behave like parentheses. So you need to do whatever operation is inside of it, like we did on that last one where we had 3x. We multiplied by 3 first, and then we found the absolute value. You cannot distribute into absolute values. So you need to work out the absolute value first before you do any distributing. All right, so that's our lesson for today. Thank you very much.